Welcome to another tutorial of the thermal system design class. So today we're gonna explore more onto the setup of the inside of ANSYS Fluent. So from last time we rechecked the general things, just as the scale, the how to check your meshing, report the quality, the different displays that we have on our problem. So today we're gonna move on onto more of the important things on the setup. So for example, if we click here on the expansion, we can see models, but we can also double click and we can see that we'll have models right here on our task page. So the models is gonna tell you what your problem is gonna be solving for. So for example, we have multi-phase, we have energy, we have viscous, radiation, we have different cases. So we're basically learning how to create a case study for this simulation. So we also have the heat exchanger, the species, the discrete phase, solidification, acoustics, structure, and potential lithium battery. So let's say, for example, that we have a viscous problem, like in this case. So if we click on viscous, it's gonna give us all these different options for the model. So let's say, for example, that we have a turbulent flow and we want to select a epsilon model. So it's basically two equations. So it gives you different things. So it's gonna tell you the epsilon model, which one do you want to use? Do you want to use the standard, the RNG, the realizable? We have the near wall treatment. We have different options. Here also we have the material constants or the constants for to solve the problem. So most of the cases you will not need to change these numbers. So but if you find in literature or because the problem is stating you to change one of these numbers, you can go ahead and you can actually modify this number. I'm not going to modify it right now. And it's going to be the same thing for the different models that ANSYS provides you for the viscous model. So let's say that you just have a simple laminar flow. You select that, you click OK, set up as viscous laminar. For example, and right here, for example, also we have our energy equation is turned off. So if you don't have a temperature change or a energy change or a thermal energy change, you're not gonna select this, but you can easily turn it on if you want and turn it off if you don't want it. So that's definitely something very important to know. Models is one of the most important interfaces inside of Fluent. So this is gonna tell you from here is going to affect every single other thing that you put on your setup. So let's go now into materials. So materials, we see that there's already some materials selected for us. Let's go here at the bottom of the task page. It says create or edit. So if we click it, it's going to give us different options. So right now, by default, we already have air and it's set up as a fluid. If we change it to solid, we have here aluminum, and it's gonna give us the chemical formula. We have different things. We have the properties in the bottom. We see that we can have a user defined, we can have constant density or new inputs. Let's go back to fluid. In fluid on the properties, we see that we have the density, the constant density. We have viscosity, constant. We can set it up as another thing, but most of the time we're gonna set it up like that. Also, if you're solving any problem and you want to compare your solutions to the solutions from ANSYS, it's very important for you to use this number, not other number that you found somewhere else. So this is gonna be because this is what ANSYS is gonna use to solve the problem that you're giving it to it. Here the order of the materials, if you want it by name or you want the chemical formula. And one of the most important features right here is that if you go to Fluent database, it's gonna give you different options. So right now I'm on solids. So we have different solids right here. We have gold, we have steel, we have titanium. Let's go to fluids. So if you go, for example, to fluids, we have all of these different options of fluids that we can run our problem through. It also comes with the different properties. It's going to tell you right here what the properties are. So something really important to know. So we close this. So define. You can also search in a specific database, and if you have the data from it, you can put it inside of ANSYS. Very important too, if you don't see a material on the Fluent database, you can input the material here inside of ANSYS. So you'll name the material, you can change or create. You can name the material, you can define if the material is a fluid, you can put the chemical formula. You'll just have to look for the density, the viscosity, or depending on the material that you have. So for example, PVC is not inside of, if we go to solid, we don't see PVC here inside of the solid materials, but you can actually look for the properties of PVC, and you can look for the density, and you can set it up here inside of ANSYS in order to have PVC results. So very important to know. Let's go now to cell zone conditions. Double click on it, and it's giving us our surface body. It's telling us that it's a fluid. Our fluid is air. It's set up to be a solid. That's basically just the domain that we're using. We can edit it, we can change it, and we can say if it's moving by frames. In this case, we don't have that. We have the reference frame, the mesh motion, the per zone. If we select this, it's going to give us the option to edit it. Let's close this. Now let's go into boundary conditions. So if we click on boundary conditions, we can see the different boundaries that we set up since our meshing. So for example, let's click on our inlet. So our inlet, if we take a look into it, we can see that there's also different things that we can name this. We can name this an interface, a mass flow inlet, pressure inlet. Let's leave it on velocity inlet right now. If you were to select another one, if you click it, it's gonna give you the options to change it. Or if you already have the one that you want and you click edit, it's gonna give you the same window. So right now it's telling you, because we only set up this as a viscous problem, it's asking you for the momentum. Let's say that the velocity magnitude of the inlet is 5. And we apply it. We can see here that thermal radiation, you cannot click on them. And the reason is that because here on models, because we turn off our energy, we cannot see it. But if we were to turn it on, we go back to boundary conditions. We click on thermal, we can see that now we can change the temperature. And it's the same thing with every single part of the models. So it's very important for you to know the specific problem that you're working, what solutions do you want, because it's gonna affect every single step of the way until you have your results. So we change our inlet velocity, the velocity magnitude, we change it to 5. If you also have the gauge pressure where you can change it, let's click on outlet. We can see that we have a pressure outlet. Most of the time, you're gonna use outflow. So basically, outflow is you're telling ANSYS that you're not worrying too much about your solution of the outflow, because it's not gonna affect your inlet conditions. And here in the flow rate weighting, if you set it up as 1, it's telling you that you're gonna have the 100% from the inlet that you already put is gonna going to the outlet. So if you set it up as zero point 0.5, you're just gonna get a 50%. That is common, as sometimes in some conditions on some domains, you're gonna lose some of this velocity, or you're gonna lose some of this fluid through the process. Most of the time, that you're not gonna use that, at least not in this class. But it's definitely something that we can apply it, close it. You can see now that the type is outflow. Symmetry, we have cylinder, we can see that it's just a wall. We go to edit. Uh, right now it's set up as a stationary wall. You can set it up as a moving wall, and you can change the relative, the rotational, the components, depending on the type of moving wall that you have. In this case, we just have a stationary. You have the shear conditions. Same thing, you cannot click on thermal because you did not select that model at the beginning. We close it. Interior surface body, that's just the interior of the domain. We also have dynamic meshing that we're not going to use right now because we're not having a dynamic mesh. So reference values, you can change your different values for any simulation. The area, you can change your temperature. Right now it's set up to be temperature. It's just set up as a atmospheric temperature. So you're not gonna change it right now. You have your viscosity again right here if you want to take the value in order for you to make calculations and everything. So that's most of the setup for your ANSYS problem, for any problem on Fluent. So we'll continue on the next tutorials.